Hello students, welcome you to this video. In this video, I am going to teach the concepts and some of the very important questions from exercise number 7.2, that is determinants. So there is a difference between matrices and determinants. So matrix means it is an arrangement, right? But determinant can be simplified and can be equated to a real number. It has a specific value. So that is one of the difference. Other difference, the physical appearance. In matrix we use the two brackets, right? So matrix we denote like this. Determinant we use this symbol. Matrix can be of any order. Matrix can be of any order, but determinant must be a square. First I said matrix is an arrangement, but determinant has a specific value. You can equate it, you can simplify this. How to simplify, I'll explain to you. Okay. Then matrix can be of any order, but determinant must be a square. It's either 2 by 2 or 3 by 3. Then a matrix, if you want to multiply, suppose A is a matrix, if you want to multiply by a number k, you multiply every element by k. Every element you multiply by k. But in determinant, not like that. If you want to, suppose a determinant is given, if I want to multiply by k, you multiply any one row alone, you multiply by k. Other elements and all, no change. Same way when you take it out also. In a matrix, when can you take a number outside? If it is common for all the elements. Suppose it is a 3 by 3 matrix. For all the 9 elements, if something is common, you can take it out. But in determinant, if something is common in any one row or in one column, you can take it out. Suppose suppose I'm converting this as a determinant. Okay. So I'm converting it as a determinant. So then the first row you can take one k outside, second row you can take one k, third row you can take one k. So you will get k cube into the determinant of A. That is the case of determinant. Okay, so these are the major differences between matrix and determinant. So matrix is an arrangement, you cannot simplify, but determinant can be simplified. You can expand it. Matrix can be of any order, determinant must be a square. Matrix we denote using the brackets, and determinant, the two bars we use. Matrix, if something is common for all the elements, then only you can take it out. Determinant, if something is common in any one row or in any one column, you can take it out. Okay, so these are the differences between matrix and determinant. Now, how to expand? I said determinant can be simplified, right? So, suppose a determinant is given 2, 1, 7, 3. So, first the principal diagonal you multiply. 2 3s are 6 minus 7 into 1. So, this is order. You multiply these two, put a minus, then you multiply other two. So 2 3s are 6 minus 7 into 1, 7. So the answer is minus 1. Suppose I take 2 minus 1, 7, 3. First the principal diagonal, 2 3s are 6 minus, that minus is in the rule. Minus, now we multiply other two, 7 into minus 1, 7 into minus 1, minus 7. So minus minus plus, right? So 6 plus 7, the answer is what? 13. Suppose it is 2 minus 1, minus 7, 3. So principal diagonal 2 3s are 6. Then in the rule there is a minus. Then when you multiply these two, here another minus minus. Here there is already a minus. Now there is 2 more minus. So totally 3 times minus. So minus into minus into minus. So it is minus 717. So the answer is minus 1. So this is how you can expand a 3 by 3 determinant. Sorry, 2 by 2. Now for 3 by 3, please listen. Suppose minus 1, 2, 3, 1, 2, 1, 0, 1, 2. One simple determinant I am taking. It is a 3 by 3 determinant. How to expand it? Please listen very carefully. You take the first number. What's the first number? Minus 1. So minus 1 into, leave that particular row, that column you leave. Leave that particular row and particular column. Now the remaining you have 4 numbers, right? Do what we did here for 2 by 2 determinant. So 2 2s are 4 minus 1 into 1, 1. So this is the first one. You take the first number, leave the row and column, you multiply the others. Take the second number. When you take the second number, you change the sign. First number you write as it is. -1, write -1. Second number you should change the sign. 2 is there, so you write -2 into. Suppose if it is -2, you change the sign, +2 into. First one no change, second one you change the sign, third one no change, right? Okay. 2 we have taken out, so -2 into, leave that particular row and that column. Now you have 1, 2, 3, 4. Okay, that 4 numbers as a 2 by 2 determinant, 1 into 2, right? 1 into 2, 2 minus 0 into 1, it is what? 0. So the second one we finished, right? Now let's take the third number. What's the third number here? 3. So you have to change the sign or not? No. First one you don't change. Second one you change the sign. Third one no change. 3 into. So plus 3 into. Leave that 3 we are taking. Leave that particular row, that column. So these are the 4 numbers you have. So 1 into 1. 1 minus 0 into 2. It is what? 0. Now just you have to simplify all these things. So you have to practice a lot of questions in determinant. Okay. Now please listen. That is -1 into 4 minus 1, 3. -2 into 2 plus 3 into 1. So -3 minus 4 plus 3 cancel. Your answer is -4. So like that you can expand a 3 by 3 determinant. Listen again. Take the first number. Leave the row and column. You do this part. Okay. So 2, 1, 1, 2. 2 2s are 4 minus 1. Now take the second number. When you take the second number, you change the sign. If it is +2, you write -2. If it is -2, you write +2. Leave that particular row, that column. Remaining 4 numbers, that 1, 1, 0, 2. 1 into 2, 2 minus 0 into 1, 0, right? Now take the third one. When you take the third number, leave that particular row, that column. When you take the third number, there is no change. First one, no change. Second one, you change the sign. Third, no change. 3 into, leave the row and column. 1 into 1. 1 minus 0 into 2. It is what? 0. So, hope you understood this. Then you can simplify. Now, I am going to teach some of the properties of determinant. If you are thorough with the theory part, the concepts, then you can do the sums easily. Okay? Please listen very carefully. Try to understand the properties. Look at the first one. The determinant of a matrix. The determinant of a matrix remains unaltered. That is, it is not changed if its rows are changed into columns and columns into rows. We are interchanging rows and columns. Rows we convert into columns, columns we convert into rows. In matrix we call it as transpose, right? So determinant we won't use the word transpose. We are interchanging rows into columns and columns into rows. Then the value of the determinant is unaltered. It remains same. Suppose your determinant is given, its value is 25. You are interchanging rows into columns. Say first row, this is the first row, you write it as first column. Second row, write as second column. Third row, write it as third column. Expand, there is no change. So that is the first property. If you interchange rows and columns, there is no change in the value. Property number 2, if any 2 rows or columns of a determinant are interchanged, then the determinant changes its sign, but its absolute value remains same. Please listen carefully. Suppose a determinant is given, its value is 25. Just assume a determinant is given, its value is 25. What I am going to do, we are going to interchange 2 rows. See, this is the first row, this is the second row, this is the third row, right? So 3 rows. We are going to interchange 2 rows. For example, interchange first row and second row, or second row and third row, or first row and third rows. For example, I am interchanging first row and third row. Third row I am writing here, first row I am writing here. We are interchanging first row and third row. No change in the second row. In that case, the absolute value, the 25 remains same, but changes in sign. So that is this property. If we interchange 2 rows, value changes in sign alone. Suppose the first one's answer is 25, now the answer will be -25 if we interchange 2 rows. Or even 2 columns. Interchange 2 rows or interchange 2 columns. Don't interchange a row and a column. Either interchange 2 rows or interchange 2 columns. The value changes in sign. Suppose if we interchange 2 times, sign changes 2 times. Minus, one more minus, so it becomes plus, right? So now here I want to teach you another very important thing. Please listen here. Suppose the first row is A, B, C. Meaning here we have some more elements, okay? C, suppose I am going to interchange these two first. So that is A is here, C, B. Then two columns if we interchange, you have to put a sign what? Minus. Now I am going to interchange these two. So this C comes first, C, A, B, right? One more minus will come, so it becomes plus. So C, so these two are same. This one and this one are same. Listen here, A, B, C. You can start with C, C, A, B. A, B, C. You can start with C, A, B. What is happening there, you know? You are interchanging 2 times the columns. So when you are interchanging means not only that A, the entire column you are interchanging. Okay, so what you have to understand here, please listen. Cyclically you can rotate if it is a 3 by 3 determinants. Here it is A, B, C and the corresponding columns are there. This can be written as A, B, C. You can start with B. If you start with B, after B you write C, then you write A. Okay. Suppose you start with B, first is A, B, C. If you start with B, B, C, A, B, C, A. B means that entire column you have to write here, B, C, A. Or you can start with C. If you start with C, you have to write C, A, B. You can write it as what? C, A, B. Actually what is happening here, you know, 2 times you are interchanging. When you interchange 2 times, minus into minus. So it becomes what? Plus. Okay, so when you do the sums, it will be useful to you. This is the same thing only if there are n interchanges. 1 interchange, minus. 2 interchanges, minus into minus, right? 2 times. If there are n interchanges, minus 1 raised to n into determinant A. If 2 rows of a determinant are identical, then the determinant value is 0. You don't need to even expand it. Suppose 2 rows are identical. 2 rows or 2 columns are identical. Please listen. Suppose they are giving 1, minus 2, 7. Then they are giving 125, minus 7 by 6, 2017. Then again 1, minus 2, 7. They are asking you to simplify this. Don't worry. Don't worry about that 125, minus 7 by 6 and all. See the first row. 1, minus 2, 7. Last row. 1, minus 2, 7. 2 rows are identical. So just you put the answer as what? 0. You can try with small examples. You can see that the value become 0. 2 rows are identical or 2 columns are identical. Then the value of the determinant is equal to 0. Now listen, if a row of a matrix A is a scalar multiple of another row, then again the value becomes 0. For example, 1, minus 2, 3. Then you have that 7 by 3, 247, 24, 201, something like that. Third row, earlier I said, if they are identical, the value becomes 0. Now they are not identical, some multiple. Suppose first row you multiply by 5. What do you get? 5, minus 10, 15. Again the value becomes 0. See, read the statement now. If a row of a matrix A is a scalar multiple of another row. So this third row is a scalar multiple of R3 is a scalar multiple of another row. R3 is 5 times R1. This we call it as proportional. If they are exactly equal, we say identical, right? In the previous example, first row and third row are identical, but here first row and third row are proportional. Proportional means some multiple of, in this case also, the value become 0. Look at the next one. If each element in a row of a matrix is multiplied by a scalar k, then the determinant is multiplied by the same scalar k. If each element in a row of a determinant if each element in a row of a determinant is multiplied by a scalar k, then the determinant is multiplied by the same scalar. See, please listen here. Suppose a determinant is given, its value is 25. What we do here, first row alone, I am multiplying by say 3. First row elements alone, only the first row element, whatever we have here, I multiply by 3. No change in the remaining. Then answer also multiplied by the same scalar. See the statement now. If each element are in a row or in a column, not all the elements, only that one row or that one column alone you multiply by a by a scalar k, then the determinant means the value also multiply by the same scalar k. If I multiply one row by 3, the answer also should be multiplied by 3. Okay, that's very important one. Now the next one, please listen. Look at this one, this step you see. What is the speciality here? Second column, all single numbers, right? Third column, all single numbers only. Only the first column you can see as the sum of two terms. Every element is the sum of two terms. Then this determinant can be expressed as the sum of two determinants. So if in one determinant, one column is expressed as sum of two terms, either a column or row, then you can write this as the sum of two determinants. How to do, in the first determinant, you take only the first elements. Only the first elements you take, A1, A2, A3. Second row, third row, just write as it is. When you write the second time, the first column, you take the second elements, M1, M2, M3. Remaining second column, third column remains same, right? Second column, third column remains same. Here, first column expressed as a sum of two terms. So you can write it as two determinants, sum of two determinants. The first column, in the first case you take the first elements, second case you take second elements. Suppose instead of plus, if it is minus in all the cases, here we put minus. Some plus, some minus, then you put plus here, the minus and all you can adjust inside. Okay, this is how you can do. So this is another important one. We have sums based on this also. And the last one, just I'll tell you what it is. Suppose a determinant is given. Two rows can be added. Value won't change. All the three rows can be added. For example, R1 is R1 plus R2 plus R3. All the three rows you add and write. When you do the sums, you can understand better. Two rows can be subtracted. For R1 is R1 minus R2. There won't be any change in value. Okay. And one row you multiply by some number and add with some other row. Then there won't be any change. So two rows can be added, subtracted. You multiply by some element and add. But you have to do for the entire row. Okay. Or for entire column. Two columns can be subtracted. All the three columns can be added. Okay. Value won't change. Okay. So these are some of the very, very important properties. In two cases, the determinant value becomes 0 if two rows or two columns are identical or proportional. If you interchange rows and columns, there is no change in the value. If you interchange two rows, you have to change the sign, right? Value remains same. Okay, now we try few questions. Look at the first one. Without expanding the determinant, prove that this determinant value is 0. Without actual expansion, using these properties, you have to prove the value 0. So when can you say the value 0? Either two rows are identical or proportional. Now let us see. See this one. Third column is expressed as a sum of two terms, no? If you want, you can split into two. That is one case. Okay. Another thing, please listen. Here three letters. The first column, what is common? See, I am taking LHS. First column, what is common? S is common. Can be taken out. If I take S outside, you will get what? 1, 1, 1. Right? Second column I am writing as it is A square, B square, C square. The third column you can see B square plus C square. What is missing here? A square, but A square is here. The last property we studied, two rows can be added, two columns can be added. So what I am going to do here, C3 is C3 plus C2. C3 instead of C3, C3 plus C2. Just I am going to add these two and write. So B square plus C square plus A square. So you are getting A square plus B square plus C square. Add this and this. So again A square plus B square plus C square, right? A square plus B square plus C square. Add these two. Again you are getting A square plus B square plus C square. Now what is common here? A square plus B square plus C square. Take it out. What will become? 1, 1, 1. First column is 1, 1, 1. Third column also 1, 1, 1. Two columns are identical. The value becomes 0. That's all. See how we did that? In the first column, what is common? S is common. Take it out. Now, instead of third column plus second column. So, you will get A square plus B square plus C square in all the three. Take it out. 1, 1, 1. Now, two columns are identical. The value becomes 0. So, only now writing work. S into A square plus B square plus C square into first column 1, 1, 1. Second column a square, b square, c square. Third column again 1, 1, 1. So the answer becomes 0. Reason you can say C1 is equal to C3, right? So totally the answer is 0. Now let's move on to the next question. Sum number 2. Listen. Show that this determinant is equal to 0. Show that this determinant is equal to 0. It's a very good question. Please listen. First row, what is missing? A is missing. Second row, B is missing. Third row, C is missing, right? So what I'm going to do, multiply R1, R2, R3 by A, B, C respectively. Meaning, first row you multiply by A, second row multiply by B, third row multiply by C. When you multiply, value should not be changed, right? First row I multiply by A, so divide by A. Dividing by A and multiply by A. If you multiply first row by A, you see first one becomes AB plus AC. AB plus AC. Second element ABC. Third one A, B square, C square, right? So first row you multiply by A. Second row multiply by B. When you multiply by B, divide by B also, right? Yes. Multiply by B, BC plus AB. Second element, ABC. Third one, we are multiplying by B. I am writing in alphabetical order, A square, B, C square. Third row, you multiply by C and divide by C. That division we are writing outside. Multiply by C now, so you are getting AC plus BC. Next one is ABC and the last one is A square, B square, C. Now listen carefully. Already we have 1 by ABC. In the second column, what is common? ABC. Third column also you can take one ABC outside. So second, if something is common in any one row, you can take it out, or in any one column. Not like matrix. Matrix, if something is common in all the elements, then only you can take it out, right? So here second column we take one ABC. Third column we take one ABC. So listen, first column remains same, AB plus AC. Second column BC plus AB. Sorry, first column is AB plus AC, BC plus AB, AC plus BC, first column. Second column ABC we have taken out, so it becomes 1, 1, 1. Third column, please listen very carefully and write. A, B, C we have taken out. 1A, 1B, 1C. So still there is a B and C. The next element we have taken 1A, 1B, 1C. So you are getting AC. The last one, 1A, 1B, 1C. What is the remaining? AB. Now listen, I'll tell you the method. See, second column is 1, 1, 1. First column AB, AC. What is missing? BC, but BC is here. So what I'm going to do, instead of first column plus third column. First column is first column plus third column. So AB plus BC plus CA. Again AB plus BC plus CA. CA or AC. Here again AB plus BC plus CA, right? All the three are same. Take it out. One more, 1, 1, 1. Two columns identical, the value becomes 0. That's the method here, okay? One ABC cancel, so you write ABC, one more, right? So first column plus third column. You must know the reason why. So write in order, AB plus BC plus AC. Again, AB plus BC plus AC. AB plus BC plus AC. No change in the second column. Third column is BC, AC, AB. Now in the first column, that element is common, right? So already we have ABC. Now we take that AB plus BC plus CA or AC common from the first column. So it becomes 1, 1, 1. Second column 1, 1, 1. Third column is BC, AC, AB. The value becomes 0. The reason is what? C1 is equal to C2 and that is our RHS. Now let's move on to question number 4. It's a very good question. Listen, they can ask even in a 5-mark question. It's a very simple one. Easily you can do that. There are different methods, but I'm going to teach in a very simple way. Listen, just to expand it. But before that, if you want, you can simplify because a lot of ones there, no? If you make few 1 zeros, the calculation will be easy, right? What I'm going to do here, First row I am writing as it is. I am not going to change the first row. First row I am writing as it is. 1 plus a, 1, 1. Second row is second row minus first row. Second row is second row minus first row. So 1 cancel, you get minus a. Here 1 cancel, you get this b. 1 minus 1, 0. Second row minus first row. I am not taking first row minus second row. Second row is second row minus first row. Now third row is third row minus first row. Third row is third row minus first row. You subtract these two. So actually 1 minus of 1 plus a. You are getting 1 minus 1 minus a, right? So these two cancel, you are getting minus a. 1 cancel, you are getting minus a. 1 minus 1, 0. Here 1 cancel, you are getting this plus c. Now just expand it. 1 plus a into 1 plus a into, leave the row and column. You know how to expand a determinant, right? Leave the row and column. This is what you have. Simplify. B into c, bc minus 0, right? bc minus 0. bc minus 0, I'm leaving it. Take the second number. When you take the second number, you change the sign. So minus 1 into, leave that row, leave that column. So you have cross multiply minus a into c, minus ac plus 0, minus ac, then minus a into 0 is 0, that leave it. Take the third number, write as it is, don't change the sign. 1 into, leave that row, that column, these are the 4 numbers you have. Minus a into 0, 0 minus ab plus ab, so 0 plus ab. Listen, so what you are getting here, so you multiply term by term, 1 into bc, it is bc plus ABC, minus into minus, it is plus AC, then plus AB, right? What is common? Nothing is common, but I'm going to take ABC common. If I take ABC outside, the first one BC is there, but A is not there, so write 1 by A. You multiply and check, ABC into 1 by A cancel, you will get that BC, right? Plus ABC taken out, nothing left out, 1. Next one, AC we have taken, A and C. B is not there, so write 1 by B. If you multiply, B cancel, you will get AC. And the last one, can you say, A, B we are taking, C is not there, so write 1 by C. So now write in order, ABC into 1 plus 1 by A plus 1 by B plus 1 by C. And that is our RHS, and this is one of the very, very simple method. Okay, just you make few elements 0, then you just expand and take ABC common, you will get the answer. Now let's move on to question number 6. Now listen this question, we start with LHS, we have to prove the answer equals 0, right? So here we have 2 elements. So one row is expressed as sum of 2 elements, so you can write it as 2 determinants. That's true, but without that also you can do this sum. Listen, you can split into 2 determinants, then first element x, y, z, here also x, y, z, 2 rows identical, the value becomes 0. Then here 2a and a, that also you can say they are proportional, you can do that. But another easy method, here x, here y, here z, here z. So what I am going to do here, first row is, listen carefully, first row is first row minus second row. Instead of first row, you write first row minus second row, subtract them and write. If I subtract x cancel, you get only 2a. Y cancel 2b. Z cancel 2c. No change in the remaining x, y, z, abc. Now itself you can say the answer 0. Why? First row, third row abc. Third row abc. First row 2a, 2b, 2c. Some multiple. So that means first row and third row are proportional. Now you can say the answer is 0. The reason, don't say they are identical. C1 and C3 are proportional. You can make them identical. If you want, you can take 2 outside. Then you say ABC, X, Y, Z, again ABC. Now first row and third row are identical. You can say R1 equal to R2. Okay, not C1 and C3. It is R1 and R3, right? So any one of the method you can use it. Okay, so if you write here itself, if you write 0, you have to use the word proportional, right? First row and third row are proportional. Proportional means some multiple of. Now listen, question number 9. Prove that this determinant is equal to 0. So here no other way. here expressed as a difference of two elements, right? We start with LHS, you split into two determinants. How? The first one, first row, first column, second column, same. 1, 1, 1, A, B, C. The first determinant, third column, you write A square, B square, C square, and the last one, B, C, C, A, A, B. But here minus is common, so you write minus here, right? So minus here, first column, second column remains same for both. First column, second column, first column, second column. Now here the first elements alone you take A square, B square, C square, that is here, and this BC, CA, AB you write here. Okay, now please listen how to make they are same. Once you make they are same, then 5 minus 5 cancel 0, right? First determinant, no change, writing as it is. Okay, first determinant we are not making any change. The second determinant, can you see what is missing there? Here you see BC, CA, AB. What is missing? A is missing, right? So first row you multiply by A, second row by B, third row by C. Okay, in the second determinant, multiply R1, R2, R3 by ABC. You know, when you multiply, you have to divide also. Value should not be changed. So first determinant, no change, right as it is. Second determinant, first row multiply by A. What do you get? A square, ABC. Second one, you multiply by B square, ABC. C square, ABC. You can see ABC is common there. Then you can take it out. Listen. When you multiply, you have to divide also. Now you can see this ABC is common. Take it out. Now this ABC cancel 1, 1, 1. First determinant we didn't change at all. Now please listen here. 1A square. Here also 1A square. Cyclically you can rotate. Already in the properties I taught, right? In a 3 by 3 determinant. Cyclically you are rotating means actually what is happening? 2 times we are interchanging the columns. When you interchange one time, you have to put a sign minus. 2 times, minus 1, 2 times, right? Minus 1 square. So there is no change. A square 1, you can start with 1. 1A square. 1 means that entire column you write 1A square. 1A square. Now both are same. So the answer is what? 0, right? It's a very simple one. So split into 2. First row you multiply by A, second row by B, third row by C. At the same time you divide also. Take it outside. Then cyclically you rotate. Both are same, so the answer is 0. Now let's move on to question number 12. Listen, it's a very good question. Listen. If ABC are all positive, ABC are all positive and are the pth, qth and rth term of a GP. You know, please listen, in a GP, nth term is AR raised to n minus 1, right? Nth term is AR raised to n minus 1. So 7th term is AR raised to 6, 7 minus 1. So here A, B, C are all positive and they are the pth, qth and rth term. Pth term is A, qth term is B and rth term is what? C. Pth term means AR raised to P minus 1. Qth term, AR raised to Q minus 1. Rth term, AR raised to R minus 1. This R and that R, 2R. You should not be confused, right? So, normally for common ratio, we use small r. Here, rth term is also there, no? So, don't be confused. So, we use capital letter. First term, normally we take it as A. Here, we take the first term as capital A and the rth term as capital R. Let A, sorry, not the rth term, the common ratio, right? Let A and R be the first term and the common ratio of the given GP. One GP is given, the first term you take it as capital A and the common ratio you take it as capital R. Then the nth term is equal to AR raised to n minus 1. Okay, the symbols only we are changing because another R is there. Now listen, A is the pth term. A is the pth term. A is equal to TP, AR raised to P minus 1. B is the qth term. B, small b equal to TQ, qth term. So AR raised to Q minus 1. C is the rth term, AR raised to R minus 1. Hope you understood that. Now please listen what we need. See the question. We want log A, log B, log C. Please listen. A we know. A equal to this one. A equal to AR raised to P minus 1. I want log A. Please, I'll explain to you some of the log properties you need. When you take log A equal to log of AR raised to P minus 1. You know what is log of AB? Log A plus log B. So you can split it. Log A plus log r raised to p minus 1. You know, log a raised to m can be written as power rule. The m comes front, m log a, right? So same way, if you use the power rule, first one is log a plus the p minus 1 comes front. So p minus 1 log r. Now please listen here. From here, can you write it directly? When you take log a, left side is log a, right? Here a, b type. So log of first plus log of second. When you write log of second, there is some power that comes front. So log a plus this power comes front, p minus 1 log r. Log a plus p minus 1 log r. In the second one, you see, if I take log, what you'll get? Log b equal to log a plus, instead of multiplication, you put plus. Log a plus, the q minus 1 comes front. Log a plus q minus 1 log r. Can you say the third one when you take log here? Log c equal to, yes, here, log a plus this power comes front, r minus 1 log r. Okay. So these are the things you are writing. Now we start with LHS. This is the question. This is LHS, and what they asked to prove. Again, we have to prove the answer is what? 0, right? So this is LHS. Second column, third column, no change. In the first column, log a, instead of log a, you write this full value. This is log a. Then instead of log b, you give this value. Log c, give the value c, you substitute. Here, this first column, if you see, sum of two terms. So write it as two determinants, right? In the first determinant, the first column is log a, or log a. Second determinant's first column is the second element, right? Yes. Now here, the first one, what is common? Log a common. Take log a outside, you will get 1, 1, 1. That column also 1, 1, 1. So that determinant becomes 0. The second one, what is common? Log r. That log r can be taken out. You will get p minus 1, q minus 1, r minus 1. You get like this. Here these two are identical, so the value becomes 0. Now please listen here. What you can do now? Here minus 1, here plus 1. Add it. First column is first column plus third column. So this minus 1 plus 1 cancel. You get only p here. Here only q. Here only r. So the first column become PQR, second column also PQR. What we are doing here? First column is first column plus that column. Because here minus 1, there you have plus 1, right? So if you add it, you will get PQR, second column also PQR2. So two columns are identical, so the value become 0. So the first determinant is 0, second determinant also 0. So the answer is what? 0. Only thing you must know, a simple result in GP, also you need the property of what? Logarithm. Okay. Now let's move on to question number 17. Very simple question. If A and B are square matrices, A and B are square matrices of order 3. Order 3 means 3 by 3. Such that determinant A is minus 1. Determinant B is 3. Find the value of, listen very carefully, find the value of determinant 3AB. Please listen here. Determinant of KA. I already said no, the difference between matrix and determinant. In a matrix, if something is common in all the elements, you take it out. But in a determinant, if something is common in any one row, you can take it. Take it out, right? Suppose it is a 3 by 3. From the first row, you can take one element outside. Second row, you take one element. Third row, you take one element. Suppose here K into A. That is, in a matrix, everywhere you K, right? Every element you multiply by K. Suppose it is a 3 by 3. When you convert it as a determinant, first row, you can take one K. Second row, you take one K. Third row, you take one K. So K cube into determinant A, if it is 3 by 3. If it is N by N, K raised to N into determinant A. Here the order is 3. So 3 can be taken out from all the rows. So 3 into 3 into 3. Then determinant A, determinant B. If the order is 2, then only 2 times you write 3 into 3. If the order is N, 3 into 3 into 3 into like N times. Okay, so that is 3 raised to N you have to write. So this is 27 into determinant A is minus 1. Determinant B is 3. So your answer is minus 81. Okay, this is a major difference between matrix and determinant. Okay, now I'll teach you just one more question, question number 19. Determine the roots of these equations. Very simple one. Just you have to solve it, right? If you know how to expand a determinant, you can do it. Here, they didn't specify anything, use properties or anything. We have to find the roots, that's all. Here, 3 ones are there. If you can make 2 of them 0, first row you write as it is, second row is second row minus first row, third row is third row minus first row. These 2 you can make 0, but here all you can see some complicated. Okay, so either you expand directly, or if something is common, you can take it out. The second column, you can take 2 is common. The third column, you can see 5 is common. If you want, you can take it out. Okay. So what I'm going to do, second column, I'm taking 2 outside. So no change in the first column. Second column, I have taken 2 outside. So this becomes 2 minus 1 x. Third column, I'm taking 5 common. So you'll get what? 4, 1 x square equal to 0. So this 5 2s are 10. It cannot be 0. So the only possibility is the determinant 1, 2, 4, 1 minus 1, 1, 1 x square is equal to 0. Now just order expansion, you can do that. So 1 into, leave the row and column, minus x square, minus x into 1 is x. Take the second number. When you take the second number, you change the sign. If it is plus 2, you write minus 2 into. Leave that row, that column. 1 into x square minus 1 into 1 is 1. Plus 4 into, last one, third number, you write as it is. 4 into, leave the row and column. 1 into x minus. 1 into minus 1 is minus 1. Minus plus 1 equal to 0. Always you multiply these 2, put a minus, then you multiply other 2. Okay. So minus x square minus x minus 2x square minus plus 2 plus 4x plus 4 equal to 0. Simplify. Minus, how many times you are getting? Minus 3x square, right? Minus 3x square plus 3x plus 6 equal to 0. You change the sign. 3x square minus 3x minus 6 equal to 0. Dividing by 3. When you divide by 3, see what you are getting? X square minus x minus 2 equal to 0. Can be factorized. Sum is minus 1. Product is minus 2. The numbers are minus 2 and 1. Coefficient is 1. So straight away you can write x minus 2 into x plus 1 equal to 0. So your answer x equal to 2. Another answer x equal to minus 1. Okay, so it's a very simple thing. Learn all the properties. We try to understand when to use which property. Then practice these questions. After that, you go through the example sums. Then try the sums what we left out. So in my next video, I will teach you the next exercise.